Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Samsul and I'm from group 5. In this video, we will learn how to convert decimal numbers to IEE and how to convert them back into decimal. So let's begin. So for further understanding, we should know what is a decimal number. Decimal numbers are the normal numbers we use every day. They are based on base 10, which means each digit represents power of tens. For example, 3.5, -2, 10, 2, and -5. Computers, however, don't use base 10. They use binary. To store decimal or real numbers in binary, computers follow the IEE 754 standard. In 32-bit format, a number is stored using 1 bit for sign, 8 bit for exponent, 23 bit for mantissa. So when changing the numbers from decimal to IEE, there are 6 steps that we must remember. The first step is we must determine the sign bit. The second step, we must convert the number into the binary. The third step is we must normalize the number. Step 4, we must find the exponent bits. Step 5, find the mantissa. And step 6, we combine all the numbers. Later I will show you what it means and how to apply it. So when changing from the number IEE to decimal, we must remember there are 4 steps we must do. The first step, we must split the fields. The second step, we must convert the exponent. The third step, we must change the mantissa to decimal. And the step 4, we must apply the formula. What formula? I will show you later. So let's go for it. So let's say for the first example, we have the number of 5.5 and then we want to change this decimal number to IEE. So the step 1, just like I said before, we must determine what is the sign. Since this 5.5 is positive, so the number is positive and the sign bit is 0. So positive is 0, meanwhile negative is 1. So since it was a positive number, 5.5 is a positive number, so it is a 0 sign number. And then for the second step, we must convert 5.5 into binary number. So how to convert? So we take the 5 first and then we divide all these 5 with 2, and then we divide 5 with 2, we will get 2 with the remainder of 1. We divide 2 again, we get the remainder of 1 but with 0 balance, and we divide 1 with 2, we will get remainder of 1. So reading from downward to upward, it will give us the number of 1012. So and then we must change this 0.5 to binary number as well. So 0.5 we must times with 2 and then it will give us 1.0. So we take the number digit up here is 1 and then we times 2 again. But since 0 and times 2 cannot be timed, and it will become 0 again, so we just take this one number to be the binary number for 0.5. So the fully binary number for 5.5 is 101.12. So let's continue with step 3. So we must normalize this number. So how to normalize? So let's take this number again, 101.1. We bring this dot to the front, so it will become 1.011 times 2 to the power of 2. Okay, so this is 2 because we bring the dot 2 times. So yeah, that's it. So we have normalized this number, so we must continue with step 4. For step 4, so we must to know the exponent. So the exponent is 2, right? So in IEE, the bias for exponent is 1 to 7. This is IEE. then we must plus the 2 exponent with this 127, and we will get 127 plus 2 is equal to 129. Okay, so this 129 we must change it into binary number. So how to change? We must divide it by 2 until we get the 0 remaining. So let's go do it for it. 129 divided by 2, we will get 60, how much 64 with the remaining of 1. We divide by 2 again, we will get 32 with 0, divide by 2 again, we get 16 with 0, we divide by 2 again with 0, we divide by 2, we get 4 and 0, we divide by 4, we get 2 with 0, we divide by 2 again, we get 1 with 0, we divide 1 with 2, we get 0, but the remainder is 1. So we read it again from downward to upward. Okay, so we will have 1 0 0 0 0 0 0 1 to the power of 2. Yeah, this is basically step 4. So for the step 5, it is for the mantissa. So just like we found the normalized number here, 1.011, the mantissa is everything after the first one, which means this thing. After the first one, it is actually 0.0111. Sorry, 011. So on how to do it, so we must padded it to 23 bits. So we take this one, 011. So we put all 0 until it becomes the 23. So 1 2 3 4 5 6 7 8 9 10. 1 2 3 4 5 6 7 8 9 10. Yeah, so this basically the mantissa. So then we must continue with our step 6, which is we can combine all the 3 parts. So what step that we need, what part that we need to combine? So we must combine step 1, step exponent, which is step 4, and step 5, mantissa just now. So the step 1, our sign number is 0, right, just now, so we put 0. And our step 4, we must put our exponent number in binary. Just now we have 1001, this one, right, you guys can see. So you put it here, 10000001, and then the step 5, we combine the mantissa. So all this number that is so long, so we put it up here. So 011 1 2 3 4 5 6 7 8 9 10 1 2 3 4 5 6 7 8 9 10 1 2 3 4 5 6 7 8 9 10. So this is the IEE number. So we basically have successful in changing the decimal number to IEE. So pretty long, right? Yeah. So in this example, we are going to change IEE number to decimal number. So we take back from our previous example, which is 5.5 just now. So this is the IEE number. So we're going to change it into decimal number. So when going to change it to decimal number, there is a formula that we must remember. That is equal to -1 times with to the power of signs times with the mantissa number, and times 2 to the exponent value minus with 127 just now. So let's go straight for it. So the first step we must to do is we must separate these fields. So how to separate? So this we have the number of 32 bits. So the 1 bits is for sign number. 1 bit is for sign number. 8 bits is for the exponent number, and the 23 bits is for the mantissa. Okay, so we can separate it. So from this back, so we can know the mantissa number. So calculate this one until 1 2 3 4 5 6 until 23. So that is our Mantissa number. So from this one we will have the Mantissa number is here. So our Mantissa number will become 011 000000000 until there is a 23 number of zero. Until there is a 23 number. So and then we have the exponent number, which is from here and here. So it is 10000001. Okay, and the one here is our sign number, that is 0. So first we need to change this exponent number into binary. So how to change? So let's go 10000001. So this one times with 2 to the power of 0, 2 to the power of 7. So 2 to the power of 7 plus with 2 to the power of 0, we will get 129. This is 128. This is 1. So 128 plus 1 is 129. So this is our exponent number. And for the Mantissa number, this is quite unique and quite complicated. So from the previous example, our normalized number is 1.011, right? So from this, we should know what is the Mantissa we going to need for our formula. So how to do it? So we take this one, the one that is in front of this dot, we have nothing to do with it. So let's say we have 1 only. So 1 plus with 0, okay, times with half, plus with 1, times with 1 to the power of 4, plus with 1 times to the power of 8, 1 over 8. Okay, so you guys might wonder how I get half, quarter, and 1 over 8 just now. So it is because if let's say we have the normalized number of 101111, from my understanding, so for after this dot, we must times all of this number with the fractions. So this is the first fraction, so we must times it with half. This one 1 over 4, this one 1 over 8, this one 1 over 16, this one 1 over 32, this one is 1 over 64. This is just from my understanding. So for our example here, 1 plus 0 times half is 0. Okay, 1 times quarter is 0.25, plus with 1 times 1 over 8 is 0.125. So we add up all this number, we will get 1.375. So this is our Mantissa number. So we already have our exponential number, our sign number, that is 0, and then we already have our Mantissa number. So we plug all this value into our formula. So -1 sign, our sign number is 0, times with Mantissa 1.375 times 2 exponent number just now we have 129 minus with 127. Okay, so let's calculate it out in our calculator. So -1 to the power of 0 times with 1.375, okay, times with 2 to the power of 129 minus 127. Okay, here we go, we get 5.5, just like our previous example. So this is our decimal number. So that's it for me. Thank you. Assalamualaikum.